Hey, thanks, Ben, for that. Can you mic on? Okay. Hey, mic on? There we go. Thanks, Ben, for that lovely introduction, and I'd also really like to thank Ben and my other friend here, Michelle, for which the presentation you're about to see would be completely impossible and wouldn't be here today. So thank you both very much. I'm Aria from Khan Academy, and I'm going to talk to you about building submarines that don't leak. So we've all heard a lot about how using reactive components can help you get tighter containers, faster cores, and more funding. One-way flow can power your fuel centers better, a virtual interface can give you better control, and flux capacitors can increase your ship's speed by about 100%. All of these fission reaction improvements are powering the largest naval fleets out there. But how do you best use these construction techniques to create airtight U-boats? I guess that's the wrong talk. This is the wrong conference. This is the one about undefined not being a function, right? Okay, let's talk about JavaScript. So sure, according to Horse.js, any large code base needs to be modular. But why? We're not going to be able to answer that question, unfortunately, in this talk. But I am going to try to answer how to make your React code base more modular. Basically, by focusing on how to encapsulate components and build less leaky abstractions. To do this, I've built sort of a very, very, very simple login modal example that will sort of start from how we would have built it when we first switched Khan Academy to React, and progressively enhance this to use sort of more and more better React patterns and make it easier to work with this code. And we're going to walk through 5 examples of some common pitfalls that I've seen us especially run into, and how to avoid them, and how to refactor code out of that. So roughly what our React tree looks like is we've got an app, and it renders some other things, but one of the main things it renders is a login modal. And while that login modal is rendered, that login modal renders 3 components: a username input, a password input, and a button. And the username and password inputs also have their own inputs that they render. So it's a very, very simple tree. I'm just trying to create as simple an example as possible to talk through some of these concepts. And sort of for a little bit more code there, and apologies on the sparseness, but this is just the render function. For the login modal, it basically renders some outer divs to handle all the modeling, and the inner inputs, and the button to actually do the submitting of logging in. So the first pitfall I want to talk about is sort of wrong lifecycle flow, which is sort of not using the lifecycle flow that React gives you to actually manage your state in your UI. And this is really easy to get into when you first sort of migrate from jQuery. So for example here, our login modal, in sort of how we would have written it when we first switched, might grab our state for the username and password out of the DOM using refs. And then whenever you submit it, it'll grab that state out of the DOM and it will submit that to the server. This works, but it's very DOM-based, and it's nice as a transition step from an earlier framework. However, this becomes difficult to work with. It's easy to get out of sync. It's difficult to manipulate this state. You can't sort of do modifications while people type things. And it becomes almost impossible to use with things that like to maintain state, such as hot reloading. Basically, this works, but it's going to become hard to modify and work with sort of the more changes we make to this. So to fix this, we want to get our state out of the DOM. And one of the easy places to put our state is Flux. We already have a Flux store set up, and we're just going to put that state in the Flux store, and our submit function can query that state out of the Flux store. The difference here, the main key difference to focus on, is that now our state is stored in JavaScript as opposed to stored in HTML. And just like we've seen with styles, storing these things in JavaScript tends to make it easier for us to work with, because React has been very nice in terms of navigating your JavaScript state. And so to sort of connect this so that the submit function works, we're going to wire up our username input to our Flux stores. And I like to do this by wiring it up in component did mount. Sort of just add a listener that modifies our state. This way all of our renders get the appropriate state. So we're just adding a listener here. So every time that our Flux stores state changes, we get a state change on our username input. And we grab out the current username value for our state. Our render then renders that state that came from Flux, and whenever there's a change event, it fires off a Flux event to modify our Flux store and thus change the render. However, this leads us into one of the other pitfalls I've seen, which is over-fluxing. And this is, we've got some components here that are very, very low level in the tree. It's an input itself that is firing off these flux events. And that means that that input knows a lot about our app world. And basically, there's two types of components, those that know about your app world and those that only deal in state and props. And knowing about your app world adds a lot of complexity. There's lots of state. You can trigger an event from anywhere, and that event can have cascading effects anywhere else. These components are difficult to test in isolation and difficult to reuse. That username input is now very, very tied to that login flow. And maybe that's okay in that case, but the more of these components you have, the trickier it is to think about where your event's coming from. And if you want to make something slightly different, have two ways of accessing logging in that render different places, doing that can become trickier. So Flux works really well for high-level components and organizing your high-level state. It doesn't work very well for low-level components, and that's basically because Flux is a big global. All of your Flux state is global, and there are changes on this. I highly recommend checking out Dan Abramov's Redux, which sort of avoids the whole state question completely. But in sort of the common implementation of Flux, these are a bunch of globals, and you want to minimize the surface area of our interface that can talk to these globals. And by doing so, you create a much easier to think about sort of global state. If everything can touch those globals, you have to look through everything to figure out how the sort of lifecycle flow of your app works. So we're going to refactor this a little bit. And we're going to do that by pulling our state out of Flux here and putting it into our login modal state itself. And we can do this because the state of like what you're typing in the login modal, we're going to pull up the Flux events from outside of our user input, and we're going to put them into our login modal so that our login modal is the thing managing the state, not our input itself. And so first thing we're going to do is we're going to wire up our login modal to Flux, same way we wired up the user input to Flux, just adding a listener and component mount. There are other ways to do this. I like this because this way the renders always trigger whenever there's a state change. Let's see. And then we're going to send the Flux actions in the onChange events that we send to our username input. Our username input is going to take a value and a callback, and in that callback that's provided in login modal, we're going to actually fire the Flux events. To make our username input look like this, our username input mostly is going to focus on the value itself and sort of passing that down to the input, and the onChange, which it's going to pass up from the input. And our username input actually has become extremely simple here in this example. I like to call these components propful components, and as opposed to like stateful components. We've all heard the word stateful before, and propful is maybe not the best word, but it's a sort of fun word to say, and really describes what you want to be aiming for. So this component is incredibly easy to test, incredibly easy to reason about. It's, in this instance, basically so small that it's almost not there. But now the state is being managed by one level higher up in the tree. Let's see. So the basic technique here is you want to sort of move your state up a little bit and use props at the lower level components to get to receive that state, and callbacks that are sent via props to pass that state back up. The third pitfall I've seen us run into is sort of a poor division of props, state, and instance variables. And in addition to Flux, these are sort of your most common three types of sort of state in React. And it's sometimes questionable sort of where does something go? If you've got some state you want to maintain, and which in these four places do you put it? So the first one in this list is props. And props should basically be for everything. The more you use props, the better things are, and there's really not that much more to say about it. But if you've used controlled components if you've seen like the react.dom inputs and all of the react.dom components that are published as a standard library, the recommended way to use those is sort of via controlled component, where you pass in a value, and in your onChange you do some state updating so that you can pass that value in again. And the basic idea here is that we want to follow that pattern for as many of our components as possible. So our username input, because we set that to follow this pattern earlier, using this is very simple. And using this looks just like using the basic react.dom components that React provides to us. which we've all used extensively and are easy to work with. Let's see. Now, state is more of something you use when you can seriously answer why not use props. And some answers for that are for temporary things that don't need to be persisted. For example, in our app here, whether or not the modal is visible is not that important. If the user reloads the page, they're not going to be worried if they lost the state that their modal was up. And they're not going to be worried if their partially typed in password is not restored. Now, if these are things that you really care about, maybe that's a valid reason to store them in Flux or something. But there's also going to be plenty of times, maybe with menus, if like a menu is open, you don't really care about keeping that state between refreshes or keeping that state between a lot of events if the user starts doing other things. In that case, component state is a reasonable thing to do. The second example here, and I'm going to be pretty vague on this one, is that state can be used for hiding complexity from your parent. And I'm being vague because I don't think as a community we've fully worked out how to do this. There are a lot of different patterns, and I'm excited to see sort of more work and development on which of those patterns work best. But if you want to sort of hide and encapsulate some state from your parent that your parent doesn't have to deal with, you're going to end up using state at some point. Possibly in the component itself, possibly in a stateful wrapper component. There are options there, and we haven't totally figured it out. But there are valid use cases for state occasionally. So for us, we're actually going to pull that, instead of maintaining our login modal info in Flux, just going to demo what that looks like in state quickly. So here we've got our username input, which has the value is still taken from state, only now that state's not coming from Flux. And the on change is just going to be a local function that calls set state on our login modal component instead of firing a Flux event. The last of these three is instance variables, which are probably the trickiest, mostly because they're the least talked about. Instance variables are things like this._myvar or anything this dot. And it would seem like this might be an anti-pattern in React because we don't hear a lot of discussion about it, and we don't see it very often in code. All of the docs on the React site talk a lot about props and state, and sort of using those. They don't talk a lot about this. But this is actually a valid use case, but you need to be careful with it. This is a good use case for non-renderable data. Anything that render isn't going to read from is a valid thing to store here. Some examples of this might be removing event listeners, which becomes pretty critical because things like this dot is mounted is becoming deprecated. Canceling callbacks that you have in flight, sort of storing tokens so that you can do cancellation or removing things. Caching things is another example. Often if you have a really complicated render, which is a very edge case already, but if you have a really complicated slow render, you might want to be able to cache parts of it so that certain parts of the JSX tree don't have to be built up again. And we actually have this in Perseus, which Ben was talking about, because we rendered like this giant markdown tree into this giant DOM node. And rendering involves like parsing all of the markdown and then outputting all of the markdown. And if other things other than that markdown change, we want to be able to just spit out the same markdown really quickly without having to do all of that parsing and all of that rendering again, which slows things down very significantly and makes it almost unusable on mobile. You can store caches on instance variables, also things like timer IDs, set timeouts, set intervals, things like that. Some of these things you could be stored on state, but if you start storing them on state, you're going to be getting a lot of extra renders that you don't need, which is going to make things unnecessarily slow. And you can avoid that, but to avoid that, you need to implement your should component update very specifically to ignore these things. You can't use things like the pure component mix-in that doesn't exist anymore, probably. And you have to be a lot more careful about these things. And really, there's not a good reason to put them there. The other advantage this gives you is that you can't set state or modify props by setting your parent state in a lot of lifecycle components, like render specifically. If you're going to cache things, you can't cache things on component state because you can't modify state in render. So one example of using these instance variables here is we are subscribing to a listener in our app to get our Flux events out. And what we're not doing is if our app becomes unmounted, we're still going to be getting those callbacks sent from Flux saying, hey, update your state, hey, update your state, hey, update your state. which, if you're like me, you've probably seen a lot of React warnings saying, hey, your component's not mounted, invariant violation, everything's broken. And the usual approach to sort of getting rid of those is to wrap everything in if this dot is mounted checks. There are a couple problems with that. The simplest one is that this dot is mounted is deprecated, so the React team isn't very happy with you using it and might take it away at some point. But the more critical problem is that that's sort of the wrong solution. And that's the wrong solution because those callbacks keep firing even if you do that. And because those callbacks keep firing, those callbacks are stored somewhere and they're leaking more memory. So every time you mount and unmount this app, you're adding another callback to the React store, which takes up a decent amount of memory, especially if this component gets mounted and unmounted often. Not common for app, but common for a lot of things. And those callbacks continuously firing are going to slow down everything a little bit. The longer your app's open, the slower it's going to get. So instead, we're going to want to unregister that listener. And to unregister that listener, we're going to need to maintain an ID or token so that we can ask that listener to be unregistered. And here I'm just going to have a token that comes from the addListener function. It's just going to be called listener ID. And now in the component we'll unmount, we can pass in that listener ID and ask the Flux store to unregister that. So why is this an instance variable instead of props or state? It doesn't make sense being props because your parent component shouldn't have to know about this. This information isn't relevant to anyone higher up the tree. Also, it doesn't really make sense on state because it's not used in render. And while it wouldn't cause a ton of problems, if you needed to change that ID by changing what store you were listening to, that would unnecessarily trigger a render if you put it on state. So we're just going to put it on the component itself, and then we're going to read it from the component itself when it unmounts. The fourth pitfall is a little vague, but I really wanted to include it because I think it's critically important, and it covers a lot of cases, and that's basically doing things at the wrong level of the tree. And what does this mean? This means that you sort of have this tree of React components, and oftentimes you run into sort of problematic cases where those components know a lot about things happening either above them or below them. Below them is a little legal because you're rendering your children and you know what those are. But knowing things above you in the tree is very problematic. It means that your component's never going to be able to be reused. Components generally shouldn't know about their parent component. Specifically, if you're ever going to grab that component and do something else with it, you're going to run into real problems if it's only allowed to be rendered in one place. So let's see. So one way that I've seen this manifest itself is through the on-change callbacks. And this is really tempting because this is really convenient. And I've modified this example a little bit from what we've seen before, in that now we've got our username, our login modal, and rendering the username input. We're going to pass in the current username state, but instead of passing in a custom on-change, we're going to pass in the set state for the login modal. And this is really easy in that if you look down our username input, all we have to do is call our onChange function with an object containing current username and whatever we want the current username of the login modal to be. But it's problematic because the login modal now has some state. One of those state fields is current username. And one of its children, username input, knows about that state and knows what fields are on the state in login modal. And login modal doesn't know all the places its state is used. So if we go to do something like refactor that and rename that state value to just username, we're going to rename it in all of login modal, but there's not a way to even see while you're doing that necessarily that state is used in a lower level component in the tree. It's not obvious if you're scanning through the code, like grepping for current username, specifically grepping for current username : things like that. It's not going to be obvious that that's modified in a child component. And if you try to use that child component in some other component, your other component's going to have the exact same state structure in order for that to work. If you just want to call it username in your other component, you're going to have to refactor it everywhere, or not at all. So to avoid this, all we have to do is pass in sort of a more specific on-change. And doing this does take more code, and then we've sort of added this change username function here. And you can do this with ES6 arrow functions are pretty nice too. Basically, you want to avoid getting funny disbindings. But here, if we make this change username function and pass it in instead, and then in username input, we only pass up the actual username, we avoid all of the knowledge of props from leaking from login modal into username input. Username input can now only change the correct prop and has an explicit contract. And renaming the current username state is really simple. You just grep through the login modal component, find all the instances, rename it. Some other examples of this, which are maybe a bit more subtle, is the username text inside of our username input component is probably at the wrong level of the tree too. Rendering the sort of display of all of these fields and text is really more the concern of the login modal. And this one's a little debatable, but if you go by the name of username input, it probably should only be concerned by the specific input itself and managing that state and validating that. Taken to an extreme, I've seen this lead to a lot of label props on all your inputs. Every input type component that's built adds a label prop, and then it renders that label before it. And this causes problems because you can't like restyle that label. And now every single input that you deal with, you have to manage like, okay, we're going to display this label, and it's a bunch of extra complexity on all of your components, as opposed to just rendering that label one level higher in the tree outside of the input itself. And then you get all sorts of flexibility in terms of like how you style that. You can put in arbitrary React elements instead of strings. Let's see. Cool. Another example is things that know they're in a list, often with some sort of list index prop. I've seen this before, and this is really tempting if you have a component that's only ever used in this list. But when you do that, you eliminate the possibility of that component ever being used outside of a list. So if you're okay with that, then that's reasonable. But there are a lot of cases where that happens only because of convenience, and now that item knows that like specific information about how its parent is going to be rendering it that's not necessarily relevant to itself. Often you can key things sort of outside of that and it'll work out better. And sort of like we looked at before, anything that knows about their parent state or prop structure is going to cause problems here. The last pitfall is what I like to call avoiding inside-out composition. And React does one very important thing, much better than most other UI frameworks, and that is it creates UIs via composition instead of inheritance. And this composition allows for sort of easy refactoring and easily pulling out pieces into different pieces. There are a lot of other benefits to it that make it a lot easier to work with, but when we think about sort of pulling out components, we often think about doing it like this. We think, here's our JSX tree, and we've got some sort of subset of the JSX tree, and we're going to refactor that into a component. If we wanted to turn this login button into its own thing, like username input and password input, and needed to attach some special behavior to it, we could do that really easily. It's really clear, just pull that out, make that the renderer, put that login button in its place. But we can actually go further than this. If we think of the login modal as doing two things, one, it's rendering a modal. It's rendering sort of the outside of the modal and dealing with all the behavior around that. Like when you click off of it, if you tab focus off of it, it needs to hide, it needs to like shade out the rest of the screen, it needs to center things. So it's rendering all of that. And it's also rendering all this login contents, all this login information. And if we think about that in those two things, this component's sort of doing too much. It's complecting the idea of rendering a modal with the idea of logging in. And what the other sort of type of refactoring we can do to address this is we can actually refactor this by pulling out the outside two divs out of this component and making a component out of those. And if we do that, we can make it into something like a modal component and pass in some form of what do we do when this modal component gets close so that it can adjust its behavior, and we can get rid of all of that extra logic that we'd have in this component otherwise. And just render the same inside contents we would have had. Now to implement this basically means becoming familiar with this.props.children. So our modal component would render the same two outer divs, the background and centering things. It would pass up events that it needs to into its parent with this .props.onClose, and then it's going to render all of the children, which are all of the JSX components that were put inside the modal component, onto the div inside of those two divs. This lets the modal component handle opening, closing, styling, focus, all of those sorts of things. And so those are sort of the 5 most common pitfalls I've seen us at Khan Academy run into when we've been switching to React. And sort of over time, we've gotten better at embracing some of the better React patterns that make it easier to refactor things and build better components that don't leak implementation into each other. And that's the end. This is a submarine fin. Thanks. Any questions? It's very hard to see up here. I apologize. Yeah.
For instance, variables, you said that you use them to do caching, right?
Yeah.
In this case, it feels like you escaping the normal React lifecycle. So what are the pros and cons of it?
Yeah. The question is, for instance variables, we can use those to do caching. But by doing that, it feels like we're escaping the normal React lifecycle. And what are the pros and cons to that? Yes, we definitely are escaping the normal React lifecycle. But so, for example, in Perseus, let's actually, I don't think I have internet, but I can probably do this. Am I getting, nope, not getting any screen share. No preferences too. Oh, fun. Okay, I'm going to try to answer this in words and maybe look at it later. We've got this big thing that renders a ton of markdown and a ton of like inputs and things inside of that markdown, and specifically a bunch of interactive components that are smaller parts. And the pros are that you can do something like this to avoid a lot of the slowness of rendering big things. React works really well if your components are all very small. When your components start rendering really long lists of things, they get really slow because every render has to spit out all of those same elements. And creating those elements might be expensive. In our case, we have to do markdown parsing. And even rendering those in React is expensive if you have a lot of them because it can't do the optimization of only this part of the tree has changed. Only modify it. It has to look at this whole component has changed and you rendered all these things and it's got to diff all of those things with the things that already exist. So we find caching useful for sort of a very few of our really long components that render a lot of things. And it does escape the React lifecycle, but if you do that you want to do that in sort of a safe way. So what we do is we know that the outside, the markdown contents, if the original markdown string is the same, then the markdown that we want to render is the same, and we can reuse it. And we have to be very careful about that. There have been plenty of bugs in the implementation of this, and probably was only originally possible because of Ben Alpert, which if you have a core React member on your team, then that's definitely helpful. But where was I going? What that allows you to do is we know the markdown text didn't change, so the markdown React components we're rendering don't have to change. And the stuff inside, we can handle that sort of manually. It's not something I recommend. It is much more of a pain to work with. But it solved critical performance problems for us. Without this, every interaction on one of these interactive components inside the markdown would trigger a whole markdown re-render, which is fast on a MacBook Pro, but not fast on an Android phone or an iPhone or an iPad or anything else. So, is that cool? Anyone else? You might have, yay, thank you. You might have to stand up and jump. Go for it. Oh, what were we using before React? We used a hodgepodge of a lot of backbone models and jQuery and handlebars. We sort of had a lot of handlebars views. We also had Jinja templates in the Python. So Jinja templates, handlebars, backbone models, and jQuery state manipulation. Yeah. Oh, sorry, question was what did Khan Academy use beforehand, if I didn't repeat that. Yeah. Sorry? Are we using server-side rendering? No, not right now. We're on Google App Engine's cloud services right now, and we haven't switched to managed VMs, which allow us access to the root box. So our options are running Python or Java or Go, and we haven't done anything. All of our code is Python right now, so we don't even have Java or Go. If we had Java, maybe we'd do like Rhino or run something to run JavaScript there. But we don't have the, I think we definitely would if we had the JavaScript running infrastructure. Cool. Anyone else? You might have to jump up and wave your arms because it's really bright. Going once, going twice, gone. All right, thanks everyone.